Good morning. Good morning. Welcome, DevOps. We're going to talk about some shell script. But before we begin, I want you to turn to the person next to you, say good morning. Come on, don't be bashful. Don't be bashful. All right.
Welcome to Shell Script 101.
All right, welcome to Shell Script 101. Today we are going to be talking about what is shell, how to use variables in shell, some common commands that are very useful, some examples of them, also PowerShell, how do you set up your profile, some tips and tricks to make it useful, how I interact with kube for bash, streamlining my dev process, and of course we have to have some fun and some jokes. This entire presentation is written in bash script and PowerShell, so if you want to follow this QR code, it links to my GitHub repo with this presentation. I'll let you use your phones for a second, and I'll move on. You can come find me after if you want to find it again. All right, so about me. I've been at SPS Commerce for 3 years. I'm a reliability engineer. Before that, I was at Target for a couple of years. Before that, I drove school buses, did a lot of climbing and camping, and this fall, I'm going to be starting my master's in software engineering at the U of M. So why am I talking about shell? I don't like to type everything. I don't remember commands that well, especially all the arguments that I have to pass in. And I want to add logic to commands. I want to be able to automate some things. I want to be able to change a few parameters, but not have to type in the whole thing. And most importantly, I like to feel like a hacker. So what is a shell? Well, a shell is a program that is a user interface, facilitates user interface. Steve Bourne created Bash, probably the most popular one that people just, if they think shell script, they think Bash, even though they don't usually use it. The born again shell. Other common shells are T shell, C shell, K shell, Z shell is the default for Macs. Fish is pretty popular, the friendly interactive shell, and then PowerShell if you don't use Linux. All right, all shells are pretty similar, but they're different. And PowerShell is more different, but still similar. Different commands, sometimes different implementations. And then the command argument syntax can be very different between different versions of different shells. And so I go to Stack Overflow all the time to remember, why isn't this working on my Mac? Or why isn't this working in my CI/CD pipeline when it works on my Mac? All right, so let's talk about an example script, kind of one that I go through. Hey, Jesse, give me a branch name.
Just because.
All right, so we're going to do a new branch feature for this repo called feature just because. And of course, I can't spell. That's why I use bash and scripts. So we're going to check out, create the new branch. And we're going to, on that new branch, and we need to make a change to the repo. So we're going to just make a nice little documentation about what time we updated, and we're going to put it to devopsdaysMSP. And to prove that it actually went to the file, I'll just output it and make sure that it's there. Yep, it's there. And I need to add that to Git, so I've added it. And then after that, I need to commit and do a nice, useful commit message, meaningful description on what we're doing. And then I need to push it. So I'll do a git push. Oh no, I forgot to set my upstream. So it actually kind of right in the middle of there, it shows the exact command that I want to do. So I can just pull that text out and have it do it for me. Some of you guys will notice that the last line tells me a better way of doing it, but I don't read that far. So I'm just going to say, do it. And it does it. So what did it do? Well, it ran the command again, and it's taking git push, and it's taking the output of the error stream and the standard output stream, and it's putting the dev null so it doesn't print to the screen, so that way it doesn't show up. And then we're looking for the line git push, finding that line, using xargs to execute it, and eval to execute the entire string without the spaces around the outside, and it works. But hold on, there's also variables we need to use. Variables are useful for all programming languages, especially scripting, and the context is very important when you're using variables in Bash. So it's based on when you first initialize or use the variable, but it's more importantly how you call the Bash script and the commands. So there's two different ways, two main ways of calling scripts. You can either source the command or source the script, or you can execute the script. If you source the script, you're using the command source, or you're doing a dot before the actual file. And so when the script finishes, the updates to the environment are persisted. Or if you execute the script, once the execution ends, it is not persisted. So let's kind of do some demos and kind of figure out exactly what's going on there. So I wrote a script called shell var demo. It calls another script first where it checks for if some vars are set, and they're not set. So then we call var demo, and it sets those variables to, wow, a demo. And then we go back and check, and they're not set because we executed the script. So sh var demo, we're executing the var demo, doesn't persist. So if we instead source it, we can see that the last check, it is still there. The state has been persisted because it was sourced instead of executed. Now, if we set the initial variable first and we still source, it still overwrites and persists the changes. Again, if we go back to executing, it doesn't persist the changed variable. It reverts back to their initial state. What happens if you run it in a background process? Anyone know? Anyone? Yeah, I don't know either. I'll do that in shell script 102. So this is a tough slide to remember. I've failed at this miserably many times. Oftentimes I'll be setting up a virtual machine or some agent, and I have to use some scripts to set some environment variables. And I'll execute the script rather than sourcing it, and I'll wonder why it isn't the variable on the machine or the container that I wanted. Why isn't it there? Because I didn't source. All right, let's go through a few common commands. First one is man, short for manual. Very useful for figuring things out when you don't have Google available to you. So if I want to look at how to use the command echo, I just do man echo. And it brings up this page of all these things, tells me the exit statuses, all the flags that I can use. But it's kind of hard to read, and I just like examples, and so I just Google things instead. All right, next we're going to talk about grep, global regular expression print. It's useful for finding matches within strings and files. It returns the line of text that it is in. So let's say I want to look for the word shell in the welcome slide for this presentation. There are 5 lines that it's on. Now, if I want to look at more of the presentation, I can use cat, or short for concatenate. So I'll do cat star star slash star. So I'm looking at all the files in this directory and all the files and all the directories in this directory, and I'm searching for the word shell. I think there's a few more times that it's used. All right, sed, stream editor, filtering, mapping, changing the stream. So I talked about streams before where there's the standard output stream, and then there's the error stream, and you can kind of tell the operating system to put it to different places. And so a stream editor allows you to filter and output it. So a cool way of doing this is I can echo out, hi, devopsdays Minneapolis. Do you like the graphics? And then I can use stream editor to change hi to hello world and make it green. Do you like the graphics? All right, xargs, execute arguments. It's useful for when you've piped input and you require manipulations from sed. And it performs the action on each term in standard out. So I want to show that I don't have any files or directories in this directory called with xargs demo in the name. And then I'm going to echo out xargs demo 1, demo 2, demo 3. And I'm going to do xargs make directory with that. And when I list all of the files again that have xargs demo in it again, we see that there are now 3 directories with that name in there. And then I kind of want to clean this up so that next time I present, it doesn't have it to begin with, and I can actually show that it works. So I want to clean it up and prove that I can clean it up. All right, evaluate. All right, it's useful for reserved words in the arguments. Also when you're using variables in a shell script. It's also a great way to know your security team. So I start with a variable foo, and I set the value to bar, because that's what you do. And then I'm going to make a command where it's echo, and I'm going to escape foo so it doesn't actually replace the value when I'm assigning the variable. And then I'm going to do a stream editor to change the A's to 4s and the E's to 3s, because, you know, it looks cool. And then I can echo the command and prove that it didn't actually execute yet. It has what I would type into a prompt, but I don't want to type it every time. And I can show that if I eval the command, I get bar with the A changed to 4. Okay, but what happens if I now change foo to hello DevOps Days Minneapolis? Well, if I eval the command again, it changes the new foo. So evaluate, you can do it when you evaluate, not when you had the variable before. But what happens if I set foo to hello, move stuff to dev null, change directory, and then rm-r-f? I don't think I want to find out. All right, read. You can read in a stream. It's useful for making scripts interactive. It's how I actually go from slide to slide in this presentation. So a prompt is different in Bash and ZSH. I found that out when I was making this presentation. It's kind of fun. So we're going to do a read, enter, reply. All right. Who has a reply? Zato? Potato. How do you spell potato? All right. So we're going to echo reply, and we've got potato misspelled. All right. JSON query. This is very nice for parsing JSON, different schemas. You can also make a CLI weather bug with it. There happens to be this really nice website where you can find out what your public IP address is. And then from that public IP address, you can hit a different endpoint at that same host, and you can find out your latitude and longitude. You have to do a little bit of cleanup of the string, because, I mean, I found the first way that worked. I didn't do it the best way. And then from that location, I can go to api.weather.gov, and for that latitude and longitude, find the URL that I want to find a forecast at. And then from there, I can curl that forecast URL, and it'll return a bunch of periods, like 10 periods. I can look at the first one, the first period, and I'll look at the detailed forecast of that period, and it'll tell me the weather for DevOps Days Minneapolis. Looks like there's a little chance of rain this afternoon, higher near 75. So careful on the drive home. All right. And there's many more commands, both fake and some with escalated privileges and permissions. And then what about PowerShell? PowerShell. Some people use Windows. Some people use .NET. And at SPS, we have some people use .NET, and so we have some Windows build machines for CI/CD pipelines. So I've had to learn PowerShell this last few years. And I actually kind of started to like it a little bit. They've got some nice naming conventions where most of the commands have a verb and a noun rather than being this kind of like condensed text. So it's really easy to read and figure out what's going on just at a glance at the PowerShell. And then also the output is in objects. So the first command I'm going to talk about is the get command. It lists all the commands that are on your machine. And I usually just use Google and then check if it's on my machine. And this tells you what commands are actually installed. There's too many to demo, so I'm not going to do that. I'm going to filter it a little bit first. But the get command actually has built-in filtering. So I can check for all of the commands that have the verb get and the noun starts with a U. And there's only 3 of them. Next, I can do select objects. So rather than JQ, everything is in object notation already, or is returned as an object rather than a table with spacing. And so I can actually select the first 5 and just get the properties I want, just list those. And so I get a few of them. Some of them are built-in functions for this presentation. But I can also filter where. So if I want to do all the processes that start with a P, I can just select the first 5 and do this as well. And password breach A, that one seems weird. All right, write error, write debug, write host. This is very similar to echo, but it's actually within the name, it actually kind of specifies explicitly what stream it's going to. So if I write host hi, it says hi back. If I write error, oh no, It tells me what line the oh no happened on. It's kind of cool. All right. And get content. I went back a little bit. It's fine. Oh, yeah. You can use get content to search for, like cat, and you can look at all the files that have shell script in the README. All right. Out file and T file. This is useful for when you're doing file manipulation and you're writing stuff to a file rather than to your output. So I can show that there are no files out file example of text, nothing there. But I can write a message, hello, this is a test, to that file. And I can get the content, show that it's there, hello, this is a test. And then I can also append to that file, PowerShell seems fun. And so I got, hello, this is a test, PowerShell seems fun. And then if I want to get rid of it, I need to make sure that the file's actually there before I get rid of it. Otherwise, get errors and it kind of boots out of scripts and doesn't do well. All right, so then I can make sure it's not there anymore. Invoke web request. So instead of using curl, you can use invoke web request, pretty much similar. And then because everything's already in object format, it's a lot easier to do stuff rather than doing JQ. So a lot more condensed, a lot easier. Get the same forecast. Again, watch out for rain on the way home. All right, let's go back to Bash. All right, profiles. So whenever you start up a shell, most shells have a default location that they look for, and they source your file. So for ZSH, it's your .zsrc file or zhrc file in your home directory. And so you can put a bunch of environment variables, export variables in there. You can put a bunch of functions that you want to use, and you can source that. So every time you start up a terminal, it sources that. You can put common things, like if I want to change the way I use Helm, do some shortcuts, ways to set environment variables for my local dev, I can put that in there, and every time it starts. Now, when you're working on your profile, a nice little tip is you create a little function that sources the source file again itself, so that way you don't have to restart the terminal to do it. All right, but how's it work? Well, I can actually show you how it works on my computer. So I like to emphasize what path I'm in and what repo. So I'm in the Shell Script 101 repo, and I'm on the DevOps Days branch, or at least I was. So if I do prompt, I can change how it looks. But you notice that I'm on feature just because it picks up what branch I'm on. Cool stuff. And I can do term refresh to refresh and resource everything if I make changes to the profile. All right, so that's how I do profiles. And then Kube, I use it for Kube as well. So when I'm playing with friends, a nice old Viking game where I'm throwing batons at the Kubes. Sorry. Kube. AWS Kube contacts, K9s. A lot of times I'm getting the AWS variables into my local environment. I'm doing sourcing and a lot of scripts and stuff, automatically changing, using Kube context. At our company, we use Helm for our deployment tool, and sometimes if the runner that's running Helm quits unexpectedly, you get into a state where you can't turn it back. So we have scripts to be able to overwrite the state to be able to have Helm then overwrite them. So scripts are very useful for Kube as well. All right, dev, you can also use it for your dev process. Most people have makefiles. It's really easy, syntactic sugar. You can package long lists into a single script file to make your makefile easier to read, reuse them. CI/CD, oftentimes it's easy to get variables, package things into zip files if you're going to put them into CDNs. Also, really easy to run locally too if you don't have the task. Sometimes some CI/CD tools you can't run locally. So if you have the script and you're able to run it locally, it helps be able to make sure that it works. All right, startup scripts. A lot of times you're starting VMs or EC2 instances, or you're starting up agents, and you need to get all the credentials there. And so a lot of times you can do that. But consider using an SDK or parameterizing for some of that if you have languages. Sometimes you don't want to push a language there. Right? Another thing we have at SPS is we do clear checks. So we are retail, we're part of the retail network. We have customers that some of their biggest business is during Cyber Week. Half their business might happen during Cyber Week. So we do not want to go down for them. We want to make sure that we're available for them. So as a team, we actually go through all of our services every year, and we're like, we want to make sure that we know how to observe these. We know exactly what we need to do, and so we actually wrote a script. We put that into a script, so that way we can automate that process, and we make sure it's repeatable. So if we have multiple people doing the same check throughout the week, we can make sure it's good. So here's a demo of my clear check script. So the first thing I do is I run the example clear check shell script. I'm doing a demo flag, so I'm demoing it. And so what it does is it changes, it iterates between all of the different environments and clusters. And in each environment, it's calling the kube controller, kubectl command to get the pods, looking for the failed, crash, and pending ones. And then I'm looking at the nodes, making sure that the nodes are actually coming online. There's none that aren't schedulable, or if they are, we know why they aren't schedulable. They can also make sure that the nodes aren't too hot. Sometimes we have queue consumers that are just all using all the CPU and kind of can do some hand-holding with the scheduler to make sure that things are not having noisy neighbors. And then we run that for all the other environments and clusters, all the other cloud providers as well. And then we can actually open up all of our dashboards. And so we can go to Grafana, we can learn how to use Bash again, we can go to the repo for this presentation, we can look at the schedule for DevOps Today as well. All right.
Who wants to hear a computer tell a joke?
Who wants to hear a computer tell a joke? Oh, Jesse wants to hear a joke. You want to hear a joke? You want to hear a joke? Cool. So how do I do it on this computer? Well, I've got a function in my profile where I just list a bunch of jokes in an array. And then I have it written so that the size of the array is calculated at runtime, so I don't have to update that part of the code, because I'll always forget to do that. And then it just returns a random joke from that array, and then I have a function called sjoke. And on Macs, there's this cool command called say, where you just put a string of text there and it says it to you. So if you return a joke and you have it say it, it will tell the joke. So let's see which one it picks. Oh, that's nice. All right, we'll just do this like this.
There are 10 kinds of people in this world, those that understand binary and those that do not.
All right.
F.
So, I talked about earlier about how prompt is used to get forward and back in this thing, and if you actually put an F in there, it's supposed to forward, and so I guess I didn't escape the string properly. So it's stuck on this slide, but fortunately it was my last slide. Actually, it wasn't. So try to get out of there. And so we'll do S8, or yeah, bash, slides, and then it is thoughts? Yeah. All right, so this is the last slide. All right, happy scripting. Have fun with scripting. Do jokes. Manual is kind of useful, so is Google. You can wrap your executable function and pass in default parameters. You can do a bunch of curl commands to a database, populate it with a bunch of fake data as well. You can execute, you can put an executable into your bin directory, and then you have additional ones. Keep in mind that when you're doing different containers and different images, there might not be all the commands there. And then keep in mind variable scope, sourcing versus execution. Loops. If you're doing loops or you're using untrusted input, consider using an SDK or a language. It's kind of a nice sniff test. If you're doing loops, you might want to use a language other than scripting. All right, thank you.